Thank you, Hannah. I know you said you weren't going to drum roll, but you did anyway, and I appreciate that. I know. You always feel bad for me. It's okay.
You never feel bad for me.
I do feel bad for you.
Yeah, bad enough.
Y'all ready? Ready or not? Okay, so whenever we get back. Let me ask y'all this before we start. Okay. Oh my God. Do you love this song? All right, so listen, this is a plug and chug. Like this is Tanuga. All right, look. On your green sheet, everybody take out your green sheet. Shut up.
Remember when I had mine out for my test and you stole it? I don't have a green.
You're the one that cheated on it?
No, I didn't. You never cheated on it. Obviously, I needed it. Yeah, you did think it. You know who cheated on it. And there it is.
That's not mine.
Yeah. Stole mine.
I don't know. I know. All right, me, for inverse trig functions, yes, I need a sheet. That's the one thing I can remember going into the exam, and the morning of, I had flashcards with those written on it, and I was so trying to. You don't use them a whole lot. They pop up in maybe a couple multiple choice questions, if that. And it's usually mainly there is inverse tan. Inverse tan is the big one. All right. I think he said 80% of the material is up there. You will. You will understand. If I think it's going to be a struggle for you, I'll let you know, honestly. I'll do evaluation. Okay. What? You want to see what?
No.
What he said?
Bad.
It was something bad.
Very sexual.
I really don't see a whole lot of point in sitting here and rewriting these for you, so I'm just going to start with just this one. Yeah. So d over dx before a function means you're taking the derivative of, think about like top times top, bottom times bottom, derivative of this with respect to x. If you say dy dx, then you've already established y equals something. So it's the derivative of y with respect to x. So it's, but it all means derivative. Yeah. When you look at these, the only thing I'm going to tell you when you plug into these is you have to follow this with a dx, like with, and whenever I say dx, the derivative of x. This is derivative. In other words, it's your chain rule. And I'll show you what I'm talking about. So all of these, whenever you see these expressions here, you always follow, but you'll know that because you have to change, right? Okay, right, you don't know that. Okay. Oh, goodness. I do not know what y'all know sometimes. I do know what you know other times. Let's do a couple examples. I don't even think that I'm going to get into. Do y'all remember? I'm not even gonna ask that. No, you don't. No, you don't. No, you don't. You remember in pre-cal, whenever I said I'm just going to show you these graphs because I want you to understand the main methods, and for a sine graph, and it was a little cut off. but on its side. And I said the only thing that might come up is the domain restriction part, but you won't use the actual graph other than the domain restriction.
Oh, wait.
A particle, Wyatt, this one's for you. A particle moves along the x-axis so that its position at any time is given by this.
Oh.
What is the velocity when t equals okay, let's do the derivative first, right? Not this is inverse tan though. All right, so listen, one thing about inverse trig functions is you know how before we've done power rule and you did power and then trig and then argument? This does not count as a power because it's an inverse, so be careful. It doesn't work like that one. Okay? So you have to use your green sheet. That's what I'm getting to. So if I find velocity, all right, what is the derivative of inverse tan? So green sheet, the derivative of inverse tan, if it's just x, is 1 over 1 plus x squared. That one you probably will remember by the time we get home. So if I want the derivative of this, it's 1 over 1 plus, what is my x? Square root of t squared, and now chain it. They will, but I want to tell you step by step so you see. What's the chain here?
1/2.
Which is 1/2 t to the negative 1/2. Are y'all okay?
But why do you do this? Like, the first day back, you go over here to the map like this. I'm tired.
Okay. Honey, for you what? No. What you have said. We'll talk about it. We'll talk about it. All right. Supposed to. By the end, I normally don't do anybody because if you're intent on dropping, you're not going to try, so it's not really important. But by the end of first semester, we're 80% through material. Like we literally, if you look at where we are, we'll be through like unit 6 by that point. I haven't finished your grades yet. All right. It said when t is 16. Yes? So you just plug in 16. This is the hardest part of this, I think, is that chain part of it. Otherwise, it's just a plug and chug, right? It's plug and chug, but then chain it. Because that's the way it started out. But your green sheet was just x. So if this was just that position was the inverse tan of x, then that would mean the velocity, or actually t, would just be 1 over 1 plus t squared. But it's not, it's square root of t. If they give you numbers like a 16 that is a perfect square, probably. So 1 over 1 plus, this is just going to be 16, right? times 1/2, and then I've got 16 to the negative 1/2. Now the negative 1/2, this one becomes the square root, yes? I mean, negative 1/2. All right, which 1/2? The exponent or the what I'm multiplying by? What is the derivative of the square root of x? But you got to do that power first, right? So the derivative of x to the 1/2 would be bring it around and multiply and subtract. All right, now I'm just simplifying. 1/17 times 1/2 times what is 16 to the negative 1/2? I am. 16 to the negative 1/2 would be 1 over the square root. I don't know what that is. What is it? 136? Tell me what that means. What have I just found? At 16. At times 16. Right. What? That's enough? You ready for the homework? Okay. If Noah can do this one. Y'all let him cook. Find just the general. I'm gonna really try to time myself so that y'all have time. No, that's inverse. This is the only time that the negative 1 does not apply as an exponent. Nothing in my life matches up. I'm just here, there, and yonder. What? Tell you what. No, this is not a particle motion. This is just find the derivative. There's an X in the answer, yes. Okay, this is not a particle motion one. The last one was, this is just find the derivative. Just find the derivative. Why what? Because your argument is more than just X. Do they really? No Robert? That's pretty cool. That's cool. Noah's almost there. Y'all encourage Noah.
If Noah gets it right, you have no more work the rest of the day and no more.
That's just literally the derivative. But your X is not just X in this problem, it's 5X to the 4th. Oh, no, Noah, you can do it.
And then I think that is.
Okay, what are you going to times it by?
Something with to do with it.
Something to do with that, yeah. All right.
What?
Just plug into the first one, right? So I know the derivative of secant is 1 over absolute value. It's not x anymore. What is it? 5x to the 4th times the square root of 5x to the 4th to the 2nd minus 1. And now all I have to do is follow this up with a chain. 20x cubed. Where'd you get 20x cubed? Chain. That's the power rule. It's just the derivative of 5x to the 4th, right? Working my way from outside in. Now, you can clean this up a little bit because 5x to the 4th is never, ever, ever going to be negative. Do you agree? Why? It's an even exponent. Good job, Sullivan. You're raising it to an even exponent. That's going to always force positive, right? So I got 20x to the 3rd over 5x to the 4th times the square root of 25x to the 8th minus 1. That's your chain. Close. What? No, because then you'd have to take it out of the, you can't split that. But I could simplify these two a little bit to give me 4 over x times the square root of 25x8 minus 1. That's really as far as I could take that one. Yeah, I just simplified 20 over 5. That's the answer. It's really, I mean, literally, if you've got these, you're just plugging in. Find an equation for the tan line at the point x equals -1. Remember what I told you? This whole unit. Oh, well, somebody go get Lee out of that room and tell her time's up. Right by Densmore's office. Like it goes Beckley, Densmore, and then her. He's not here. So the things that we did in these prior units, finding the equation of a tan line, particle motion, all that we keep doing. We're learning new ways, boys, of finding derivatives. Okay? Tell me what I need to find an equation of a tan line. A point and a slope. A point. Literally every time I work these problems, this is what I do. I write point, I write slope, and then I start determining how am I going to find each one of those things. So how am I going to find a point? That's right. I have half a point, yes. Okay. So if half the point is -1, the other half of the point do we have? Yeah, we do. Oh, shoot. Thank you. All right. Okay, where is the inverse cotangent, or where is the cotangent -1? Because inverse means where is this happening? So where is the now what's cotangent mean? The flip of tangent, right? But if it's
I'm not pulling out.
okay, so this one, you have to think about your. Oh, this is terrible. Oh, I didn't want to get into this. I didn't want to get into this. I didn't want to get into it. Okay. I know, but I got to show you this. We're going to do it.
We saw a wreck in the parking lot.
Take out your calculator for just a second. Take out your calculator for just a second. All right, this is why we don't have time to do our homework in class. Take out your calculator. Graph inverse tangent. Second tan. Every one of my tabs just closed. Inverse tan. Second tangent. Second tan x.
I didn't know we needed a calculator.
Oh my gosh. It probably is. I also never shut it down. I just close it. Inverse tan. Inverse tan. I'm making the math wish list right now. Get out of here.
Alright, it's just a tangent graph sideways.
Okay. Tell me again, but Logan, it should just be a piece of the tan, like it shouldn't be every single one. Okay. Yes. All right, listen. It couldn't be every right. Why, Miguel?
Another one because then that's not something.
That's correct. All right, look.
We're doing code tangent.
No.
That's what we started with.
Oh, yes.
Why are we graphing tangent?
Okay, do. Here's the point that I'm getting to with this. Whenever we do these inverses, we restrict the domain so that it's a function. Miguel is right. If I'm talking about inverse tangent, I only go from negative pi over 2 to pi over 2 because otherwise I'm not a function anymore. It wouldn't maintain its functionality. So when I'm trying to determine where the inverse cotangent is -1, I have to stay on the right side of the unit circle. Now, where cotangent is -1 is the same place that tangent is -1. Where does that happen? Negative pi over 4. Why can I not? Where's your circle? If I'm on the right side of the circle, right, why can't I call it 7 pi over 4? Because I have to be between negative pi over 2 and pi over 2. That's the hardest part about these, I think, is understanding these restrictions. All right. So, inverse tan, domain restriction, is from negative pi over 2 to pi over 2. Because otherwise it wouldn't be a function. That's one of those, remember in pre-cal, and I gave you, and I said the biggest thing to remember is what the domain is of these. You can also graph inverse sine and inverse cosine and see their domain restrictions. What I'm getting to here is, even though at 7 pi over 4, the tangent value is -1, this is not in the domain. So I have to use negative pi over 4. Because I have to be between negative pi over 2 and positive pi over 2. Okay, I don't want to get bogged down in this because literally there might be a multiple choice question on this, and that's going to be about it. But I really wanted to do one with a tan line. Kind of what? let's just go forward. Understanding. All right, look, if I have my point is -1, -pi/4. How do I find my slope? Derivative of what? Of that, right? So dy dx is, what's the derivative of cotangent? I'm going back to my green sheet, or the inverse cotangent. Is there a chain here? No, because it's just x. Is everybody okay? Plug in what? Look at y'all. Plug in -1. So what I'm doing is derivative when x equals -1. Y'all think you're not, but y'all are really good at tan lines now. Y plus pi/4, that's the slope. That's this point right here. That's okay, that's where, let me do one that doesn't have a domain restriction like that. That'll be a little bit easier for you to see. Yeah. Let's do another. Let's migrate to some homework problems. Tonight you have on this one for the inverse. I usually always give you the inverse ones for a while. I'm not going to say the whole green sheet, but the inverse ones, I don't remember that either. No. Calculus is used a lot in maximizing and minimizing functions, like maximizing and minimizing cost, revenue, things like that. And I'm sure some other engineering things. I don't know that Camden has a lot of professions that would use calculus. I will have an answer to that for you. Yeah. Yeah. Together, or are y'all working to do it first? I'm gonna let you cook. What? On the Delta math. I know, I've heard from a lot that it was too much. My apologies. That's what, yeah. You're waiting on me. Be very careful with the chain of this, because this is actually a double chain. Based on human creation of chaos. Thanks, Sullivan.
When Eve did that happen?
All right. All I did was plug in first. Right? And then I chained it. So when you chain it, think about just finding the derivative. If I asked you what's the derivative of the square root of x squared minus 1, well, you would say power and then argument, right? So that's all I did here. Does that make sense? No. For that one, yes. Oh, you're talking about, well, I would say on this one, you'd need to clean this one up just a little bit, and I'll show you why. The half and the 2x would the half and the 2 would cancel, leaving an x. This is an extra square root in the bottom. So I well, oh, this one, yes, that one does. Yes, sorry. Times 1 over the square root of x squared minus 1. And this is actually not 1, this is an x up top. Okay, let me show you what I did. Stay with me. This cancels, right? This cancels, right? X stays up top. This is a negative exponent, so it goes down to the bottom, and the 1/2 means it's a square root. Go with me now? And then I would probably just combine those two fractions. So I end up with x over x squared times the square root of x squared minus 1. I would not try to combine these by any means. Because whenever that radical and that squared cancel out, it leaves me with x squared minus 1. And I could actually make this 1 over just x if I want. And technically, when x is positive, this just equals 0. I haven't plugged into anything. Where did I plug in? The blue? So the blue, all of this is just the derivative of inverse tan. This second part, this is my chain. Sure? Logan, get out of my desk. All right, let's do another. Yep. So it was a double chain. I had to do, if I asked you to find the derivative of this, right? Because this is the same thing as x squared minus 1 to 1/2, right? I did power, and then I did inside. So the power leaves everything inside alone, and then I multiply by the derivative of the inside. What else? I had x over x squared. Uh-huh. From that 2x on the end. Did I ignore the what? This squared? This one? Oh, right here? Left. So this one canceled with this one. But this is just because the whole argument was a square root, and the rule is that it's 1 over 1 plus x squared. So whatever that whole thing is, I square it, and that whole thing is a square root.